Hello everyone, welcome back to another GhostEngine devlog episode. This is the first time I am showing my face, so whew, I'm nervous. Um, Either way, in today's video we will go ahead and start implementing this user story. Oh, by the way, I went ahead fast without telling you what's going on. So, off camera, I went and created a few user stories here. They are inspired, if you remember, from nope here from this sketch we did, I think, in episode number 2. So based on this, I created some user stories, and I also created a milestone for you who are used to it, the Scrum working methodology. That's basically that. So let's open this sprint. Here I put the user stories in order, both as priority and as dependency. Why I'm doing this milestone stuff? Because I can choose some user stories, set a deadline for them, and also compared to this issues view, this milestone view can it's here it's possible to reorder the user stories. So that's all I wanted to say about this let's say project management part. Let me know in the comments below if you want me to dedicate a video or maybe more videos to this part of the work done for GhostEngine, because quite a lot of work is also done off camera. Things like planning, grooming the user stories, so on and so forth. Now, okay, we are here in our map, in our first sprint, and let's go and deal with the first user story. Here, what do we need to do? Yes, we need to, we will consider our GhostEngine applications, which can be games, which can be desktop utility applications, or maybe headless simulation. All of them are basically simulations. So for a simulation, what we need to be able to set up the first stage of the simulation, to have some simulation steps. These simulation steps can be executed once or many times in a loop, and we will do some cleanup after us. And one more important thing, we don't want to be tied to a windowing system. Yes, maybe 90% of the time we will use a main window or maybe even child windows in our GhostEngine applications, but as I mentioned, we have cases for headless applications, like the server for a multiplayer game. I even mention this example here. So the runner can have its own state. Okay. For various reasons. I don't know. Sky's the limit. Unit tests. Okay. An application can run itself using an assigned runner, and the runner can execute a given application. Okay. So with this in mind, let's go ahead and implement this. We start by creating a branch, and I call it one from the from this user story number. So one and the title is application runner. Okay, application runner. Okay. Now let's go back to the code. So last time we added this entry point for an application. Now let's go and add this runner part. So we mentioned that our runner should be able to have its own state, but we also don't want to tie ourselves to a particular implementation of a runner. So we will start first by creating a not trait, okay, trait called application runner, and we require two things from the implementers of this trait. First, we require them to define a run function that takes a mutable reference to self, and when we execute the run, now I'm not sure if we should take a mutable reference to the application or we should take ownership of the application. I will start by going with a mutable reference, and the second thing we want, so in Rust the story with casting pointers and so on and so forth, it's quite limited for good reasons, don't get me wrong, but I still want the ability to get from a base trait to a particular concrete implementation. So to be able to do that, I will require implementers of application runner trait to also implement as any. For this one, I think it's enough to take const reference to self, and we will return from here. Let me go with the full path to it, an std any. What any will provide to us? What's wrong here? Okay. We will get a reference to an any, and we need to put this keyword here. By the way, let me hide the sidebar. Okay. Another thing that we want is to have a runner for our application, and because we want it to be, let's say, not generic, if we will be talking about generic, it means something else. It will be dynamic. Even the keyword here is telling us that it's dynamic. So this is an application runner, all good and dandy, and we need to create an application runner for our application when we create an instance of our application. So for this one, so we have two choices here. A choice is to actually have an optional boxed application runner, or we can have a default implementation of a runner that's executing our simulation, well, it will execute the setup stage, the shutdown stage of our simulation, and only one step of the update stage. We'll see what I mean in a minute. If you ask me, I will rather go with this one step runner kind of thing. So for that, here we will want to create a new instance of run once runner, I will call it. Okay, it's complaining about this. Let's create this one. So public struct run once runner. We will implement application runner for run once runner. So for the run method, we will go like application dot on startup, application on update, okay, and an application on shutdown. Okay, go away. Okay, we have those things, and for any we will just return self. Now let's go ahead to the application and implement those methods. We will add them here just before run. So we have pub function on startup, suitable reference to self, and for now we do nothing. We are just scaffolding this part. So here we have shutdown. Oh, come on. Down, and here we have update. Okay, good. What's next? Okay, it complains because the runner is not used. We'll ignore that for now. So we created the trait, we created the run once runner, and what else? Yes, the next thing we want to do is to be able to set a runner for our application, to set a runner to the application itself. So let's do that. Pub function, we'll do that with setter slash builder function, because our application can be instantiated and then configured using the builder pattern, but I'm doing them with the application object itself. I'm not doing them with a separate application builder object. So let's go ahead, we do runner. But you know what, now I see something. For the builder methods, I will rather prefix them with the with keyword. Okay, replace now for runner mutable tends to self, and as a parameter the new runner, and this one for this one I will not require the user to give us a boxed runner. Instead I will accept here anything that implements application runner, and then I will assign to the runner field, a boxed, no, a boxed new, what's going on, new runner. This is more to have a nicer API. Okay, why may not live long enough? Do we have some suggested fixes? Yes, we have. Let's also require the application runner to be static. If you don't know, this line here, it's equivalent with this one. So instead of implement here, we take this. Oh, come on. It's this kind of stuff. If I comment this, okay, I'm missing a curly bracket. So as you can see, those two are equivalent, but I prefer the nicer looking one. I can just delete that. Okay, next. The title. We have an error here. It's in the sandbox main. It's here. Okay, I just needed to save the file. It seems that the rename refactoring it's not saving the file. It's editing. It's renaming the, I don't know, the field, the function, or whatever, but it's not saving the files. I saved that. No more complaints. Now, what I should actually start with are some unit tests for our runner and application. So let's add that now. It's not too late. It's never too late to add unit tests, but as my experience told me, if you start from the beginning with unit tests, it will make your life much easier. So let's add tests. First, we want to check that we can create default application. Default, okay. Next, what do we want to check? Can set custom title and set and get. We will check both here. So we'll have an application. We will set title, custom. Okay, and let not actual, expect the expected value must be custom, and the actual value is app.title, but not the field, rather a getter for the title. And here we check those two for equality. We check that the expected is equal to the actual value. If not, the test will fail. Let's go ahead and implement title generated method. Yes, that's what I want. I don't want it to be pop crate, and I want it to be next to the setter, or not. No. what I will rather do is to split the implementation block in more parts. So the first part will be builder methods. The first part will be getters. Okay. Then the third part will be the lifecycle methods. Okay, lifecycle method. Something. Okay, we need to set the return time to string slice. Now the thing is that the title. Oh, come on. I had it here under my eyes. So the title is actually a known string allocated on the heap. To return it from the getter, we will do like this. We will go to self and get the title, but we will not return it as is because, as you can see, it will complain. We will borrow it, and now it is happy. Back to the tests. Okay, only with those two tests. Let's go ahead and run them. So to run the test, we go like this. Cargo test. We will run the test only for the GhostEngine project. GhostEngine. Okay, and execute. And something fails. So this test failed. Why? That means that the title we get is not custom. So here we assign the title we get as the new title. And that was just a small mistake I noticed there. Okay, it fails. Ah, my bad. As you can see, they are actually the same. The problem is the assert type here. We don't assert that they are not equal, we assert that they are equal. Come on, stupid mistake. So everything is okay now. What I will rather do is to actually have a small bash script for this, because I'm lazy and I don't want to remember all those parameters. So back to the editor. That's I don't know if you remember, we already have this check shell script that's doing basically what the continuous integration pipeline is doing. So for that, let's create a new shell script, and for this one, I don't know exactly how to select from the keyboard. Right, I'll do the mouse way. So I have this. Okay, and I will save it in the GhostEngine project root. Yes, next to the check shell script. I will save it like test ghost engine .sh, save. Okay, and now I need to set the executable flag to run no, not run, test ghost engine. Okay, and let's check it out. Test ghost engine, perfect. One more thing, I want to clear the old terminal content. Oh, now it's much nicer. Good. So let's get rid of this, close this too. Next, we want to check that we can set a custom runner. We do a test that checks exactly that, not that. I want a test. Okay, set custom runner. For this one, I will just create a structure custom runner here. Implement application runner for custom runner. Okay, so for those we do nothing. Silence the warning about an unused parameter, and for this one we will return self. And to check that out, we do application, not that, this application default with runner, custom runner. Okay, we save. Unused. Oh, this one. No, I don't need that. Yoo-hoo! The tests are passing. Now let's take another look at the user story. So, any test created to cover. Okay, I'm not sure we've been written all the unit tests, but this one, not even those. So an application can run itself using an assigned runner. Okay. Let's have the test. So can run application, and for this one, similar with what we have here, we'll have custom runner. Okay, and another one more thing, I want here a value. I want it to be fine, so I will go with 932. Okay, then here when I set the runner, I'll initialize that with 0. Okay, I initialize that with 0, and now I want to make sure that when we, because we are in this together, when we do this app.run, so when we run the application, we want to make sure that this runner was executed. Basically, that's what we want. And this is the scope of this value, because we initialize it to 0, and then when the runner is executed, we increment this value, and then we will check that the value is increased. Okay, so we have the application, we are running it. Next, what do we want to do next? Next we have actual, not actual, expected. We expect to get a 1, but the actual value it is, and how do we get that? We get that by doing this. We have the application, we want to get the assigned runner. We want to take the assigned runner and then do as any, and then to downcast it to our concrete type. You'll see in a minute why I want to downcast it. So let me hide this again, and also let me enable word, not word, oh come on, word wrapping. So I want to downcast this one to our concrete implementation that's called custom runner, and okay, we need here those. Okay, we don't have a runner getter yet, so let's go ahead and implement it. Public function runner, self here, and we get a constant reference to the runner, to a dynamic application runner, and we do it like this, self.runner. We can't return the runner itself because it's boxed. We need to take it as reference. Nice. So we have some warnings. Unused variable, it's complaining about the value. So, about this value, so let's fix that. Okay, so this downcast ref, what is doing, if the downcast succeeds, it will return a none, and if the downcast succeeds, it will return a reference to the concrete type we are specifying here. Now we go like I think we do a map or I think it is, yes, map or. So if we if the cast fails, I want to get the default value of -1, and if it's not failing, I want to get the value of value. The value of value. That's nice. And now we are sect equal expected and actual. Why I'm doing this -1 if the cast is failing? Because I want to differentiate between not incrementing this value and the cast fail. Maybe there is a better way to test for this, but I prefer to do it like that. Maybe I will change my mind in the future. Okay, so we have this. Let's try it out. Oh, it fails. Why? Let's investigate. So we are running our application, but our run is doing nothing. Doing nothing at all. So for this one, basically what we want to do is this. We have self runner and no, runner.run, and this takes a mutable reference to the application, so self. But we have two problems. The reference we get here is const. We want a mutable reference, but then we arrive at another issue. Wait, complaining that the runner. So basically, the borrow checker tells us that we try to modify something that's we try to modify something that's actually already borrowed as mutable. So to do that, to solve this, my idea is to do like this. First, I will take the signed runner out of the context of the application using this std memory take function, not take, replace. We want to use replace. So the destination, what replace is doing, like it's described here. So we have a field in our application, in this case this runner. So we want to go there where the runner is, take it out and return it to us, but at the same time replace it with something else. So the application object stays, what's the word? Consistent. So we want, what's the first argument? The first argument is a mutable reference. So a mutable reference to self.runner, and we want to replace it with run once an instance. And for this one, yes, I need to box it. Where's the prompt? Okay, here. Box a new. Oh, come on. Okay, now it is happy. And at this point, we can do runner.run, not up, but self. And we have another problem. Cannot borrow as mutable as runner is not declared as mutable. Ah, okay. Wait. Do this. Not there. Come on. Here. Okay, so we are running our application, but there's still a problem here. It is the same. So let's tag it as mutable. Nice. Let's see. It fails. And it fails because the cast fails. So let's think a little bit about this one. I don't want to do debugging, but let's try to reason about the code. And if we can reason about the code, we'll do live debugging. So what are we doing here in this test? Okay, we are declaring our custom runner. We implement custom runner straight for it. Then we create our application with our custom runner with a value, initial value of 0. That's good. Then we run our application and we expect to get a 1. And then what we are doing here, from our application we get the runner, we don't cast it. If the cast fails we get 1, otherwise we get the actual value. Yeah, I know what's going on. Let me show you. So I have this application, and here we ask the application to give us a reference to its application runner, but it's the tricky part. When we executed run, so when we executed this, here we replaced that runner we set when we constructed the application object. We replaced it with a run once runner, and of course we can't cast a run once runner to a custom runner. To show you what I mean, just for jiggles I will comment this, do this, and I will just cast here to run once runner. And okay, just ignore that, yada yada, everything is okay. Let's try it now. Okay, some more, but you see now the cast succeeded. So coming back to our code, let's revert this stuff. The solution, and I don't know if this is the best design, but again, this is how I see the API of GhostEngine to look like. So first, let's comment this first. We take come on, we take runner outside the context of self. Oh, no, I will rather word it like this, context of the application. Okay, and replace it with run once runner. Okay, now we execute and then we put back the original runner. We do that by doing self runner plus runner. So this should solve our issue. Let's check it out. Failing. Now the cast succeeds, but the value is not increased. So what we are doing here, we test that an application can with runner. It's a better name for the test. And yes, here when the run method of the runner is executed, we just do self.value plus equals 1, and boom, that's done. At this moment I think that's everything we needed to cover in our user story. So unit test created to cover application functionality develop. Yes, we've done this for the title customization, and also we added this test for being able to set a custom runner and to actually use it. So we are covered. An application can run itself using an assigned runner. Yes, this is implemented and it's covered with this test. Okay, done. And here a runner can execute a given application. Ah, yes. What this means? I still want to give you the possibility to structure your code like this. Let me this. So, can run application with custom runner. With assign custom runner. Okay. And here we actually want to check that can run application with custom runner. So again, let's copy paste this part, not this part. Okay, until here. Copy that. We put it here. We paste a custom runner, but this time we'll just have a custom runner. We don't do anything fancy in the run method. Do nothing. I think in the future I will add the background music to those videos. I know that I'm not doing live streaming because I'm yet uncomfortable to do live streaming. I rather prefer to record as if I would do live streaming, and at least rewatch myself before publishing. Okay, so I have this application. We don't need this to be mutable, and now I want you to be able to do this, to have, instead of setting the custom runner here, I want us to be able to do this. Let runner equal custom runner, and to do this, runner dot run application. Consider mutable borrowing, yes, and the runner must be mutable. Okay, what's wrong here? Cannot borrow up as mutable. It is not declared as mutable. Okay, that's done. But actually, you know what? You know what? In this case, a little bit trickier to test, because at this moment we did not implement the part with on startup and update, but I think this test is good enough for now. So let's check it. So everything checks out. We here, all good and dandy. So we are done. Now let's commit our work. So, one more thing before. By the way, let me stage everything. And two things we need to check now. Let's run the check shell script, and it's pleased with what we've done. Besides the unit tests, the check shell script, let's remember ourselves, is checking, also is doing a cargo check. The test is checking that the format of our code is following Raspberry's practices, and we also run Clippy on it. Clippy is basically a series of linters. So we are done with that. Now we can go ahead and commit. So this one, it's on the engine part, so let's tag it as engine core, and what we did here, add not us add application runner architect. Okay, I'm missing. Okay, architecture. Okay, commit. Let's push. Oh yes, push this to origin. You know what? Yes, let me go through a pull request workflow. So let me push this one. So now this should be available here. So we have our branch here, and yes, we want to compare and to do a pull request. We want to merge and develop from this branch, and let's describe here a little bit what's going on. So engine core. Oh yes, the title is good, but let's describe a little bit what we did. So this one closes number 1. Okay, I don't want to add details here because I'm mentioning here that this pull request is closing the user story number 1, and if we go here, I can see that for user story number 1 we have the details here. Maybe I will change this in the feature, but it's fine for now. So assigning myself to it, it's something I like to do. Labels, well, labels, it's something that has to do with engine core, and it's a feature. Okay, let's add it to the milestone. Let's create a pull request. The pull request is done, and now the continuous integration kicked in. Let's see some details about this one. Okay, come on. Oh, I can't, I'm nervous. I want to get an okay from the continuous integration too. This one finished or is still waiting? Oh, okay. Things are starting starting to get green. Come on, come on, come on, come on. What's holding you up? I know I executed those steps on our local development machine, but yeah, so everything is okay. So that's all for today. That's everything for today. If you like this kind of video format, please let me know in the comments below. Personally, I prefer this kind of format because I don't lose time cutting the videos, preparing and so on. At the same time, you get access to the not the full, but at least the coding part, the full experience. And then you as the watcher, you can decide, okay, skip this part, I will play this part as twice the speed. You can go back, you can watch I don't know, half of the video now and come back to the other half next week, next month, and so on. I want this to be a journey we have together, and I want you to get the feeling that's the real thing about programming. Programming is not just smashing the keyboard. Requires also thinking and okay, you may have a plan, as we had today with our user story. Where are you? Where's the user story we implemented today? The user story we implemented today is this one. So we had a plan here, but as you saw, while implementing it, we faced small issues. So I think it's a good experience to see someone that has programming experience how deals with this. I don't consider myself a guru when it comes to coding, but we are here together to learn from each other and to get better. And definitely, I already feel I got better after I've done this user story. So before you go, please like this video if you enjoyed the content, and also please subscribe and click on the notification bell down below to keep to be able to be kept updated with new videos that are published. Until next time, have a productive day. Bye bye.